So what you're looking at now is a National HRO-50. And if you recall from the last video, this was a receiver that I took apart. It was a receiver that was in the junk pile. It was crusty, nasty, and pretty much about to go to the junk pile. But I saved it, I picked it up and I cleaned it up and I put it all back together. And let me walk you through what I've done so far. And I want to talk about something else. I want to talk about something called the product detector. I want to talk to you about single sideband. Now, this is a great receiver. After I got it to work, after I aligned it, after I got everything peaked, it's a great receiver. It has superb sensitivity. Don't be mistaken. These old receivers can be a great asset to your ham shack. Like this one right here, it's a great receiver. It has great reviews online. It gets awesome reviews from fellow hams. So I think don't pass this up. The National HRO-50 and the 60, both are boat anchor receivers, but they can be great receivers. So this is what I've done. As you can see, the IEF cans are painted. So I took everything apart. Just let me backtrack. So I took the whole thing apart, piece by piece. I don't have a video of that because I just don't. So what I've done is I've taken everything apart, cleaned the chassis. The chassis was full of grime, full of grease, full of dirt, and I polished it. All I did really use was some scouring pads and some Ajax and a lot of elbow grease. So that's what first thing I did. Take everything apart, cleaned it up, and back here I painted the transformer. I took it apart and I painted the choke, polished all this stuff because it was grungy. Took the IF cans out. For the hell of it, I just went ahead and painted, and I just painted whatever I had in the shop. Added new wire. So yeah, as you can see, I have everything marked for alignment, which I already did. I've been using this receiver now for a couple of months. And let me talk to you about something. This receiver works extremely well. The only thing that it can use an improvement on is single sideband. So I went online and I'm trying to figure out how come this receiver doesn't pick up single sideband like the modern receivers. I mean, don't get me wrong, you can get single sideband. It works fine, but sometimes the signal comes in muffled, or sometimes the signal comes in really low, and I can't figure it out. So I went ahead and realigned it, put new components. Still can't figure out why certain stations in single sideband are just not coming in as clear as I wish. So what I've done is taken the coils out. I also realigned the coil. It helped a bit, but not much. And I ran into something online a few months ago. Well, a few years ago, but it jarred my memory a few months ago. And let me show you some things that I've come across. Single sideband for your boat anchor. So here's a bunch of stuff online that you can put together as far as a kit for your boat anchor. And for all of you who are using who are familiar with this type of receiver, y'all know there is two sockets. What's an accessory socket and one is a crystal socket. So I thought to myself, why don't I build a product detector and make this work and see if it does work. So I went online and I researched, and this is all the information. There's a bunch of stuff online, bunch of kits, bunch of ideas. from tube type to transistor type product detectors. Now, I'm not going to go into detail what's a product detector. I'll share a link, but for you ham radio operators, you all know what that is. It's pretty much a mixer. A mixer, for lack of better definition, all this is a mixer that takes the IF and mixes the IF with the BFO and produces a tone or a sound that that you can hear, and that's single sideband. And here's more stuff online. Product detectors. You guys can pause the video and read if you like it. Take a look at that schematic. So I've done some research. I went online. I studied these schematics. And I went online and figured out what other people are using. And I looked at other schematics from other receivers and tried to figure out what they're using. Like the Hammond, what's the Hammond? What they're using? Drake, what's that single ham radio? What's it using as far as single sideband? What type of product detector? And if you go online and just study other schematics, there's a lot of stuff online you can do. And there's, right, for example, there's the Collins product detector. Very simple, straight to the point. Get your FM detectors, but I'm not doing that. So yeah, so I was putting something together and I figured out, hey, let's put a product detector and let's test it out, see if it makes an improvement. And I tried to figure out what tube to use. Most conventional product detectors use your basic B6E. Shit, I can't read. 6BE6. Simple pentode. And I wanted to use something else, a different type of tube, because I've been reading about that tube, and not a lot of people are happy with that particular tube. So this is an outline of a simple product detector and how that works. So let me show you what I came up with. I came up with this. So I came up with this online. Well, I didn't come up with it. This is already somewhere online. All I did was adapt a few components and add a few components. But this is what I'm going to use. I'm going to use a 6J6 tube. And I'm going to connect it just like this. Well, I did connect. I made one of these just to, I didn't want to tell you, but I made one of these already. I put it together. Let me show you how that works. And let me talk to you about why I chose the 6J6. This is a twin triode. And it's a radio frequency. It's used for radio frequency as an amplifier, an oscillator, or a mixer. You can also use the 6AU, a 6SN7. You can use one of those, or a 12AU7 as well. But I found out that this particular tube produces a lot of gain, and it works very well. I've used I already built this product detector. This one right here. You can use, like I said, you can use any 6SN7, but I chose this one because it has a lot of gain and it sounds really nice in single sideband. So yeah, I already built this. It works. Now let me show you what it looks like. I made that little sticker there. There's an off and on switch, and I'll talk to you about the off and on switch and why that's important. So there's the 6J6 tube. Let me put the camera down and let me take this apart and I'm going to show you. Let me show you, hold on, let me take this apart. I'm going to show you what the insides of this receiver. So yeah, this is what I put together out of junk parts. Now these are all junk parts for my junk pile. This was an old case from, shoot, where was this from? I forgot what it was, some sort of an adapter. And there's an off and on switch. So before I take this apart, let's look at the schematic. So the off and on switch is connected to the last IF and the audio output. So what I did is I put a double throw switch there. So when I'm not using this in single sideband, I can just turn off the switch and it works in AM fine. The problem with this is that if you connect this and switch to AM on your receiver, you will lose a lot of gain. And there's a way to wire that whole thing into your receiver where you can just flip the switch up in the front, down here somewhere. But I don't want to do that. I just wanted to make the less intrusive connection as possible. So that's why I put that switch here, the double pole switch. So when I know it's a hassle when you want to use single sideband, you just flip it on and you get your single sideband product detector engaged. And you want to use AM, just turn it off and you can use your AM. So that's why I used that switch. I know there's a better way to connect it, but I wanted to do some less intrusive connection on my radio. And I'll show you in a minute how I wired the radio. So let me take this off. So here you have it. And put that down. So all these parts are just from junky parts. There's your 2.2 millihenry choke, RF choke. I found that online. And that little pole right there, the little tube that comes from the top to the bottom. I just got lucky when I was looking for something to plug this in and make this work. And there you go. Very simple. Very easy. It uses a 6J6 tube, a couple of resistors, a couple of capacitors, and that's it. That's your double throw switch, and it engages the single sideband product detector, and it turns it off when you want to use AM. Like I said, you can wire this on your receiver where you can just flip the switch up in the front and it disengages the AM and it engages the product detector and vice versa. But like I said, that requires you to remove some stuff and unplug some stuff and undo some wires. And I wasn't having any of that. I wanted to keep it as original as possible. And if it means just off and on switch on the top and just popping the hood open and then engaging the switch, then it is what it is, you know. So let me put this back together and I'm going to flip over the receiver and I'm going to show you how I wired this to make it work. It's very basic. I'll These are the pin numbers on right here. Pin, let me zoom in. Pin 4, 6, 7, 3, 5, and 8, and that represents the pins on your tube socket. Pin 4 is your last IF that you have to disengage that, and your audio, you have to disengage that when you switch over. And the reason being is because when you tune into AM and this is engaged, it will produce some sort of inductance or added inductance unless you just disengage, because you have that 100 picofarad silver mica going to ground and your 100K going to ground. So that's it. Very simple, very basic. Like I said, there's a lot of schematics online. There's a lot of product detectors online, different ones, different tubes. I just chose the 6J6 because it produces a lot of gain. It's quiet and they're very cheap, and it's a small form factor. I don't have to pop a big old 8-pin tube socket on top. I can just use a 7-pin twin triode. And this is a really neat tube too. Let me zoom in. So like I said, this is a really cool tube. So if you want to build one of these, you can. Let me show you what I found. I found this little enclosure from an IF can that wasn't working, so I'm gonna use that. And here are the other pieces. That's the bottom. This is from an old socket that I had. So what I'm going to do, I'll make another one. So what you can do is you can hot glue, or no, epoxy this. Let me get to the epoxy this down there. You know, and then put this on, and then somehow wire it the way I did over there. Punch out the top and put a socket for a maybe a 7-pin 6J6, and then wire it, put it together, and then there you go. You have another plug-in for your product detector on your National. So there's a lot of ways you can put this together from a junk pile, and this is what, like I said, this is what I was able to find. This is a 8-pin socket, but I'm using a 7-pin, so it's a little bit hole's a little bit bigger, but no big deal. This is all for fun. I'm just trying to have fun with radio. So if you have any questions, let me know. I'm going to go ahead and put this back together, and I'm going to test. I'll show you how I plugged it in, or how I have it wired in, and then we're going to test it. And I want you to see for yourself, or at least hear for yourself, the difference between no product detector and having the product detector. I can tell you one thing right now, it makes a huge difference in single sideband, and in terms of clarity, in terms of audio output and sensitivity. Once it's engaged, once the product detector's engaged, you can hear a big difference in terms of, like I mentioned, audio clarity when the other person or the other person is speaking in single sideband. Okay, enough about me blabbing. Let me put this back together and let me show you what I've got going on, okay? Be right back. Okay, so here's the receiver on its back. For those who are following at home, just want to wire this up as well, just pay attention to the orientation when you flip it over, okay? So let's go through and talk to you about wiring this up. Oh, before I do that, I want to show you what else I found. Another schematic of another product detector using a 12AU7. You can also, like I mentioned, you can also use the 6SN7 or 12AU7. So this is a node schematic that I found, and pay attention to the one that I put together. Pretty much the same thing. The only difference that I've used on mine, I used a 470 picofarad for better, higher filtration to higher frequencies. This one's just a 220. You can use a 2 to 2.5 millihenry. I just found whatever I had in stock, which was a 2 millihenry, but everything else is the same. I used a 10 microfarad at 350. They're using a 32 at 350. It doesn't really matter. That's just for cleaning up. And a 20. I have an A20. I'm using a 100K to ground to pin 5. They're using a R3 and R1 2.2 meg. So you can use this if you want to use this schematic and make your product detector based off that too. Go ahead and pause the video or take a snapshot of this video. If you want to use this one, I think it's a better bet. It sounds a little bit better. I like I mentioned, I did build this one together. I put this one using using this tube. It doesn't have, the product detector doesn't have as much gain and clarity as that tube. This tube is a winner. So there you go. So let's go ahead and show you how to wire this up. Now let me just remind you, you're wiring this up on a National HRO-50. You can do the same thing on your 60. Works the same way, has the same pin out. So the first thing you want to do is the CW or the BFO input. Okay. So now, like I mentioned, your receiver on the back, on the when you flipped it over, remember I showed you have two sockets. One is an accessory socket and one is a crystal socket. So we're going to mess with the accessory socket. We'll leave the crystal socket alone. The crystal is the one on the right and the accessory is the one on the left. So the first thing you want to do is you want to wire the BFO to pin 3. So how do we do that? So you use get yourself some RG58 coax and do it the way I did it. Let me try to zoom in there. You tin the shield and you solder that to the socket. That's your ground. And you solder the hot to pin 3, just like it tells you right there. Pin 3. Pin 3. And you want to go ahead and run that cable. I'll get some lighting here so you can see. Run that cable all the way down. All the way down to your BFO right there. Shield it to chassis and the hot to pin 3. See that? And that's it. So you want to run your coax cable, RG58, pin 3 to ground, bring it all the way through. That little hole was already in there, so just pull the cable, string it up over here, and connect it. Let me see if you can see. Okay, so that's the first thing you want to do. And that's your BFO input. Now let's focus on the last IF cable. That's already existing, so that's this cable right here. It's already there, so there's nothing for you to connect. It's already plugged in. That's your last IF. Okay. Sorry about all the shaking and the shade. Okay, so that's it. And your audio. Now your audio, this is what I did. This is your audio connector right there. And that is pin 5. Okay, that's your audio. That was already existing. Goes all the way up and it comes over here. Originally, the pay attention here. Let me stop the originally, this is your audio cable right here. That cable originally was soldered right here. Okay, what you do is you clip it, bring it over here. That's your CW single sideband audio output. So you clip it from here, which is your, that connection right there. Since you're not going to be using the NF, what is this thing again? Let me back up. That's this one right here. That's your NFM. So you're not using your NFM anymore. I mean, I haven't used that in ages. So that will be no longer used. I'm sure there's a way to connect this a lot simpler, but there's a lot of wiring to do, or moving wires around. And like I said, I'm not trying to do that. I'm just trying to keep it simple. So what I've done is I remove that cable right there. That's your NFM. Cut it. Don't try to desolder it because these are sensitive. And if you try to put too much heat, you will lift and it will warp this wafer. Just clip it and solder it and tack it here. And that's your audio. Okay? That's this cable right here. That's your audio. And that's it. The power is there already. Everything's there. So all you're connecting is your IF and your BFO. IF and your BFO cable. Well, no, this one's already there, like I mentioned. Just your BFO cable. You have to string it along. And this is already there. All you need to do is just pretty much cut it and jump it over. Now so that's how you pretty much plug it in. So let's talk about the receiver now. Let's talk about all the work I've done to this. So these are all the new components that I put in. I also labeled the tuning for alignment. Now on this receiver has, I don't know why National used the worst tubes, 7-pin tube sockets they can find. They've used some really ugly, crusty tube sockets that are very flaky and tend to fail. So what I've done is I removed those tube sockets and just upgraded to a better tube socket. So let me show you. This is what the old tube socket looked like. I mean, you plug in your tube there and it's being held by a miracle. These little pins right here are so flaky. You just jiggle it and it loses connection and then it reconnects again. So I removed all those 7-pin sockets and I added a better quality tube socket. 7-pin tube socket. So that's the first thing I did. I removed all these tube sockets for better connection, better reliability. So I added tube socket here, tube socket. Okay, so that's what I did. New capacitors. I also put all new resistors. High-end 1% for low noise. This resistor right here, it's I think it's a 15K. It does get hot, so make sure you put a minimum 2 watt. Higher wattage better, but 2 watts fine. And for the IF cans, I took the IF cans apart and I dumped the IF transformers in ultrasonic cleaner, gave it a bath, removed the old cable, old wires, and put new fresh wires. This one, fresh wire for all the IF cans and the BFO can as well. New cable. I also installed a 2.22 microfarad capacitor across, which pin is that? Pin 1 of tube socket, the 6SN7, pin 1, and the other to ground. And this is to slow down the CW or make it a little bit more clear as well. So that's what I added. It made a slight difference in sound quality. So once again, and I think that cable right there is goes to your automatic gain control. So that's what I added, that capacitor. Oh, what's also really important that you get right is this combo right here. See this combo right here? Capacitor. Let me bring up the schematic so I can show you why that's important. You got, I think it uses a 100 microfarad, 100 picofarad, and a 47K capacitor. That's an important component you have to get correct, because it creates some sort of, I forget the term. It creates some sort of impedance matching to the first IF coil. So this is off. If this is if you have a different value, and this is different value, when you try to align this, you're going to be way out of specs. And that's this part right here. Let me see if I find it. Shoot. Can't find it at the moment. It escapes me. Oh well. Anyways, sorry about that. But this is the where it connects. Oh, that's your first. So it's gonna be one of these tubes right here. This one right here. So make sure you have the right components, the right value. So when you update your receiver and start replacing components, these two parts are very critical, that you have the right value and you have it right on the dot, because this produces an impedance of some type into your coil. Okay, so you have to get these right. When you start doing alignment, it does make a big difference. And this is pretty much it. As you can see, I use higher end components, less noise. And like I was telling you, this receiver sounds amazing. I'm going to hook this up and show you. It uses 247 microfarads at 450 gaps. So I removed the old capacitor. Put this one in. Let me show you all the parts, just so you are aware of what I took off in terms of parts. Where are the parts at? Oh, geez. Well, I don't have it with me. Sorry about that. So let's hook everything up so I can show you. Like I said, you want to use that product detector. We're going to plug that in, and I'm going to show you what it sounds like and how it works. Okay, so hang in there and let's hook this up. Okay, so all I have connected is a long wire antenna. I have it across across the shop. It's about 100 feet long. And here's the product detector. And it goes right here. So let's test this. Okay. Now let's plug this on. Let's turn this on. I have fluorescent lights in the shop, so what I'm going to do, I'm going to turn off all my fluorescent shop lights because I need to upgrade and get some LEDs, because as you know, these fluorescent lights really cause drama with AM or with radio. Okay, so sorry about the darkness. Let me, okay, that's on. Let me turn it off so you can see. Okay. Let's pick up a station. Okay, let's switch the product detector off. Okay, it's off. Where's my vehicle?
I did it yesterday with, I think, 150. So I'm going to go over it again with 100, rough it up. Well, I'm going to do exactly what you say to do, so. And then I can apply
2
or 3 coats. So,
Ready?
I don't want to go low. I just got to do it. 24 hours.
Look at this.
To the first coat.
Okay.
And so yeah, we'll see.
Watch.
I think I'm going to do it in a couple of coats.
Oh yeah, no, do the sandpaper, make sure you clean it, and so they're not having you do any primer, so that stuff's direct to metal.
Yeah, well, I'm not putting it on metal, you know that, fiberglass. But yeah, no primer, no nothing. So all I gotta do is rough it up.
See the big difference?
Usually with it says acetone or
You see how clear it sounds and how much gain you get?
yeah, I'll do that, and then we'll go from there.
Yeah, I kept thinking aluminum, and you remind me now, like 10 times that it's fiberglass. It'll sink
Turn it off.
eventually, Mark.
Okay. See, sometimes I don't remember what I've done 4 minutes ago, so, but, just gonna, I think I'm gonna apply.
See how it sounds all muffled?
So, I'm not gonna go very heavy the first time, and
Watch.
the second time I'll make it a bit heavy. So, and if I got anything left, I'll do the roof, because I don't have a headliner in it, it's just bare. Yeah, if I have enough left, I was thinking about doing overhead, so, that's all up in the air. I don't know if I'll do that or not. It all depends on how much I have left. So, yeah, it's supposed to do a 6-foot bed, 2 coats. So, and, inside of the car is like half that. So, I should have plenty enough to do the ceiling or the roof, whatever the hell you want to call it. And yeah, like I said, we'll see.
Oh yeah, that'll go good. Yeah, and that's always a smart thing. Your first coat, you're never trying to get full coverage. You just want to get a thin layer on there. Even if you see stuff looking through, that's good, because that all adheres, and then the second layer adheres to that. It's good.
Yeah, you'll have enough to do get up the ceiling there and elevate some good sound deadening, so that'll work out very good for you. Yeah, it'll kind of, give it a finished look, because, yeah, you just,
Turn it off.
It looks like a big mismatch of whatever, so. And I'm really not gonna, I don't think I'm gonna sand the ceiling, because
Turn it back on.
it's really rough as it is. So, and they went
Big
to
difference,
rough
doesn't it?
up, and it's already rough,
So, there you go.
I'm just gonna go with the
there you go. If you guys want to start building your own product detector for your national HR-50, you can use this schematic right here, or you can use that schematic right there. Like I mentioned, I prefer this one. This schematic's been online, all over online, so I didn't reinvent it. I didn't do anything different to it. I just add a little twist on mine. I just add a little different components, which is whatever I had in the shop. So there you go. Product detector installation on your national HR-50 or HR-60. You can hear the difference. I hope you enjoyed the video. I know it was a bit too long, and maybe a little bit, I was rambling a little bit, but please like and subscribe if you like what you see, and it helps me and it encourages me to make more videos for you guys. You have any input or suggestions, or you guys want to comment, please comment below and let me know what you think. Let me know what you're using, and we'll go from there. Thank you so much for watching, and I hope to put more videos out for you guys, and we'll talk some more. 73s. Thank you very much. Bye-bye.
Stuff, plastic, yeah, all that, you know.
Yeah, a lot of people don't even know what plastic aging is anymore. You know, and yeah, I did that to my motor.
You know, that takes time. So, you know, but it's well worth it. You know, all your tolerances, make sure they're all the same, or, you know, within a couple of tenths. So, yeah, it all works out.
Yeah, but we're not using plastic gauge, but we got tighter tolerances. But plastic gauge works good. But yeah, what we had to do with the crank is to get the tolerances, we had to do 2 sets of bearings. You know, because as you know, we go on ones on the bearings, and so we needed to have, so we had to use one side of the bearing, and the other side of the bearing of the 2 sets to get the clearances that we wanted. Yeah, Roger, what's your clearance? 1,000 or less than that? Just under that.
Oh, okay.
Oh, okay, right on. Yeah, yeah, my engine's at 1,000 all the way through. Yeah, no, so it's all good, but we're doing it. So, like I say, when you come up here, hopefully you're up early.